Hello and welcome to the fourth project of my series of Arduino board video tutorials. This one's simply titled Servo Motor. First thing you notice here in our schematic diagram is a servo motor. Now we'll control this by this component over here called a potentiometer. And you may recognize this portion of the diagram here. Looks like a resistor. Well, um, a potentiometer has three pins on the outside and a knob that you can turn. Inside of it, you have a fixed resistor. One end is connected to 5 volts and the other one is connected to ground. And you have this middle pin that's, referred to as like a wiper. So as you're turning the knob, this will adjust back and forth, basically dividing this fixed resistor into two halves. And the voltage that's read across this resistor will adjust, and that voltage will be read, um, will be sent out to this analog pin here, and that's this will be an input, and then um, that analog signal will be converted to a digital signal, and then we'll send that to pin 9 and send it out of pin 9. So this will be an output. Notice that this symbol here, this means that this is there's pulse width modulation here that will be used in this, as far as like controlling the servo motor. And also what's important in this circuit are these two capacitors here and one here. And the way they're wired here is that they're wired uh, they're wired in parallel with the potentiometer and one with this servo motor here. The reason capacitors, basically they store electrical energy, and that electrical energy at some point can be released back into the circuit. Now as the servo motor moves, when it initially moves, it draws more current than when it's already moving. So the fluctuation from the draw on current will affect the entire circuit. And so what capacitors can do is release energy back into the circuit to smooth out that fluctuation. So consider like turning on a device in your house that draws a lot of electrical current, such as the air conditioner. You may notice that if there's any lights on in the house, that they'll briefly flicker for a second, and then the lights will return back to their normal illumination while the AC is running. But that's just one example of how a component can create a fluctuation in electrical energy in a circuit. And so here we don't want our motor to behave erratically, so that's why we have these capacitors here in our circuit to make sure that it's functioning correctly. So um, let's move on to gather the components that we need to build out this circuit.